Hi everybody, welcome back to the channel. I'm Dan Murphy, and today on Talk Tech to Me, I want to talk Monte Carlo simulations, what they are, what they're useful for, and how anybody can use them to solve really complex problems. So let's get into it. Well, first and foremost, the name. It is derived from Monte Carlo casinos, and the reason behind that is because it's really based on randomness. At the heart of it, that's what it is. Just like the roll of a dice or the spin of a roulette wheel, Monte Carlo simulations rely on randomness to determine things. In simple terms, a Monte Carlo simulation is a way to model real-world outcomes that have a lot of uncertainty or unknown factors around them. Instead of trying to calculate one perfect answer, it calculates thousands or even millions of possible outcomes based on random choices and showing the full range of possibilities and which one is the most likely to occur then as well. The main places you will probably see them are financial institutions, stock brokering, essentially trying to do any kind of mathematical forecasting ahead of time. Project management is another perfect application for them as well. So is healthcare and epidemiology. Got that one right. Now, it comes in three main parts. The first one is to define the possibilities. So identify the things that are uncertain, like the stock market returns or project delays, and give them a range of possible values, i.e. The shipment of the new iPhones is not going to arrive for 12 to 14 days. That is a variable. It has a variable range set then as well. So you need to define all your possibilities. Second stage then is to run the randomized trials. So using a computer to randomly pick values in that range for the uncertain items, and it's going to run these calculations. And it's going to repeat this thousands of times. Thirdly then, it's going to analyze the results. It's going to look at the outcomes, see the full range, and the most important, how often each one of these occurs within each range then as well, to give you the probability of each occurrence occurring then as well. Does that sound a bit complicated? Sounds a wee bit highfalutin mathematics. Up until very recently it was the kind of thing that was reserved for people using the likes of Python and big data analysis to run these kind of simulations then as well. But as it turns out, through these AI, you can do it on any computer in the world now. You can do it on your cell phone if you really wanted to. You can do it in Excel. So let's look at a real world example. Okay, I'm going to use the example of building a house. Imagine you want to build a house in 100 days. I know this is a gross exaggeration and an oversimplification, but let's assume that. It's going to take, you want to have it done and ready for 100 days. There's three main factors to this. There is the bricklaying, the blocks that are going to make the walls, and we're going to give that a range of 20 to 30 days. Second phase then is the joinery, so putting the roof on, putting on skirting boards and doors, and we're going to give this a range of 10 to 40 days then as well. The third variable then is going to be plastering, and plastering can take anywhere between say 20 to 40 days to complete then as well. So you can see then we have three variables with three different variable date ranges then within them as well. So what is the likelihood of all of these occurring? So we need to look at A plus B plus C, essentially your three variables, and they need to essentially add up to less than 100 days. The second thing we're going to do then is we're going to essentially assign randomized values to A, B and C. And then we're going to see what the total then is between A, B and C put together, and we're going to do this 10,000 times, and then we're going to see which way the data lies then as well. So in this simulation, it's going to give a randomized variable to A, so anywhere between 20 and 30, B 10 to 40, and C 20 to 40 then as well. So you're going to come up with a number that's going to be either at any end of those extremes of those three values added up. It's going to run that 10,000 times, and then afterwards we're going to have a look at the data and see where it got us. I'm going to show you how to do this in Excel. Okay, here we have my Excel file. This took me about 2 minutes to create, and I used AI to essentially guide me and give me the formulas for it. First column is your trial. So if you want to run this number of times, you can essentially add a different value for that. I've stuck the number 1 in, and I've made 10,000 rows of this. The second one then is your bricklaying, and it's very simple, equals random between 20 to 30. So essentially it's going to give you a randomized number anywhere between 20 and 30. For the joinery, random number between 10 and 40. And for plastering, a random number between 20 and 40 then as well. And then the last one is total, and it literally is sum, brackets, and then the three values, sort of B, C and D put together then as well. And you can hit F9 and it'll randomize your number every time, giving you a new set. And then this is done 10,000 times. So now we have our data set, and now the third step is to analyze the data set. So I'm going to select the total column, I'm going to go to insert, and then I'm going to go to charts. And for this one, the best chart, oh, it's actually already highlighted for me. Well, let's see if we can go into all charts. I want this one. And what this one gives you is a better representation of where the data lies. Whoa, that's massive. I'll bring it over here. I don't want to hide my lovely face. So what's this showing you essentially is once the 10,000 simulations are run, this is what it's returning as it goes, the most likely possibilities then as well. And you can see if you select any one of the bars and hover over it, it's going to say, so data point 17, value 645. So 645 times 17 days has occurred. That doesn't sound right. Hit 9. And every time you refresh your data and randomized number, you can see that the data is coming back pretty much uniform every time, with some slight variations. I'm not sure why these three are sort of significantly lower and constantly lower than as well. That is quite bizarre, but you can see there's very much a bell curve there as well, so that the most frequently occurring one is this one here in the middle, and then all you do is sort of look up what that number is. I'm guessing it's going to be probably about the median or the average of what those are. Label your data, label your graphs, so you can see which these values are sort of corresponding to when it comes to your data set then as well. But I would imagine this is going to be probably the average number that these three are going to sort of bring you back and then as well. So yeah, you can see very quickly how you can come up with a problem, define your your three variables then as well, and then define a range for these variables, and then run a simulation on 10,000 results. What's the most likely this one's going to occur? And you don't even have to do this in Excel. Before the invention of sort of big data and grid computing and all those other lovely mathematical terms that really crunch through this, it would have been financial institutions buying supercomputers, this kind of mathematics. You can just give AI this problem now and ask it to run the simulation for you. You can even ask it to present you a graph like this on the far side then as well. So using AI, you can essentially take a lot of the legwork out of actually doing Monte Carlo simulations then as well. If you are in project management and somebody does ask you how long is a house going to take to get built, you're not going to be able to tell them exactly the date and how long it's going to take, but you're going to be able to show them the most likely possibility that's going to be. And for me, that's a lot closer than where we were before we started this. On to the conclusion. And so there you have it. That's how to run a Monte Carlo simulation in about 5 minutes. Like I mentioned before, this kind of thing would have taken weeks to prepare the data, to evaluate it, to run your simulation then as well, to analyze it on the far side. With the use of AI, you can actually get it to run these things for you on your behalf using their resources and all their computing in the cloud. It can take seconds to do now as well. So if you do want to try work out the possibility of certain events, let's not leave the chance. Let's run through a simulation and see if AI and these kind of data models can do the legwork for us. I hope you enjoyed that short video. I've been Dan Murphy. As always, like, subscribe for more content. I'll see you in the next one. Bye-bye.